Okay, so welcome to the second module of our OPC series. This is the second module. In this module, we shift from theory to the hands-on applications. Okay, some of the examples of hands-on application. Okay, so previously what we have seen is what we saw was we saw that how the OPC UA is structured. Okay, and also we saw how the address space works, and also we saw that how the data flows between the server and client. Okay, so now we are going to follow some of the examples that and in these examples how we will see how to set up OPC server, and how to define the nodes and the variables, and we will see how on the client side we read, write, and subscribe to the data. How at client side what we do is we read, write, and subscribe to data, OPC data. Okay, so whether we are working in a real industry environment case or just exploring as OPC server, this module will give us some solid foundation. So let's dive into the real world of OPC. Now in this example, we demonstrate how to connect an Node-RED, to simulate to a OPC server, which is which is a process OPC simulation server. It's free. You can download it and you can try. And we did some few experiments on the OPC node, the Node-RED in the last labs, in last classes. So the flow starts with the function block that initiates a request. So this is a function block that initiates a request to read from the specifically from OPC UA server, and then the OPC UA client is configured to actively read from the server. So this is the OPC UA read from the OPC UA server, and then this data is given to the OPC client. Okay, and then in this debug here we see the reading from the OPC server. So for example, this is the simulation server. We have the process OPC UA simulation server, and here we have some of the simulation tags. Here we can see, for example, this is a constant value variable. This is another the counter. This is the random one, and these values are generated or from the simulation server side. So it is running and it is exposing several simulated variables under this simulation folder. Okay, so in this case we are connected with this sawtooth. This is the sawtooth variable, and this sawtooth variable is being read, and its value are available on this debug here on the debug side in the Node-RED. Okay, so this is on the right side. What we see is the debug window here, this one, and we can see the values which are coming here. So this setup is is an excellent example or entry point for running OPC UA client server interaction, and it does not need any uh, physical sensor, PLCs, or anything else. Okay, so this is the server, this one, and the Node-RED itself is it's a kind of a client, OPC client. Okay, so client on the Node-RED, and server is your process OPC. Okay, so after completing this video, I will also show you how it works on my as a video on my recording. Okay, so I will skip this right now. This is how we actually configure when we need to connect the OPC server in the Node-RED. We have to install in the Node-RED. This is in the Node-RED. So if you are familiar with in Node-RED, you will look for the OPC. You will come to the install, then OPC, and then uh, you will install this Node-RED contrib OPC UA. And next is, once we have this thing available, we will bring an inject node. This is the inject node. Inject node in Node-RED. And in the inject node in Node-RED, what we need to do is, when we double click and configure it, this is how we will give it a name. And this is the most important thing, this one. And what we do here is we go for for the variable that we need to configure, the OPC UA item or variable that we need to read. Okay, so we will go to that one, that variable, and then you see the node ID. There is a node ID here, and in node ID it has mentioned that NS. Node ID has two things, NS and it's I. So I equals to 1001. We will see in the next slide what is NS and ID means. So there is something which is NS. Okay, I will explain it later. And there is another variable I. So these two variables they should come into this. They should come here into the message topic payload, and ns3 I equals to this, and also we need to provide this data type. So the data type will come here as we will write it like data type equals to, and the data type is int 32, int 32. Okay, so this is I captured the configuration while I was making the demo. So this is how we have to configure the variable in the Node-RED. Okay, so this is the configuring in client side, which is the Node-RED. Okay, and the information is collected from the server. Okay, server side. Okay, after doing this thing, we can also mention that what is the repetition. If yeah, so what is the repetition? So interval, for example, we can select for every 1 second. I just selected this one. Okay, we will come back to this. Now, NS is basically what NS. So in OPC UA, the namespace is it is playing a sort of a critical role. It is a critical role. Okay, and ensuring that the uniqueness and avoiding the naming conflicts. So each node in the address space is mainly namespace is especially maintained for two purposes. Number one is uniqueness, and the second thing is avoiding naming conflicts. Okay. So each node in this address space, whether it is a variable, method, object, or type, uh, is identified not just by its name, but also by the namespace it belongs to. So they actually, everything belongs to a namespace here. This is one thing. Okay. So everything belongs to a namespace. I should write it. So the variables or these objects belongs to, let me write thing, every thing by mean this variables, methods, and objects variables belongs to namespace. Okay, this is one thing. The second thing is the namespace is simply a numeric index. So for example, if we see, for example, n is equals to 3 and I equals to 1004, it means that we are looking at a node with identifier. We are looking at node identifier 103, and the namespace is 3. Okay, so why do we need this? We can just imagine that we have different vendors. Okay, so you can imagine different vendors, different vendors, and our systems, and they define our systems. They define similar objects. Similar objects. Okay, so when they define similar objects, for example, let's say temperature sensor. So each with different implementation, the namespace will allow the clients to distinguish. Okay, so in that case, the namespace will allows clients to distinguish between between these variables. Okay, similar variables between similar uh, names. Okay, so NS3 is the namespace index, and I is the unique identifier of that namespace. Okay, so together, and by the way, these together they are called node, 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 and then ID, node ID. Okay, so this is called node ID. So this structure gives OPC UA its flexibility and scalability across the industrial systems by ensuring that the meaning of each node is preserved across the platforms and vendors. Okay, so this ensures the namespace. It ensures flexibility as well as the what you call the scalability in across the industrial systems. Okay. Okay, now this is example 2. In this example, we are demonstrating how a simulation server, this is the simulation server we have, simulation server for OPC, this one, process, uh, and how this interacts with another standard OPC UA client, which is called OPC UA Expert. So on the left side of the slide, what we see, the process server is running, and with a variety of These are all the simulation variables, simulated data at server, OPC UA server. Okay, and here it is value. And here we are looking at its value, its data type, the period, the maximum and minimum values, and here is its graph. So the current value is shown live, and on the right side here, we see that once this server is connected to this OPC client side, we will be able to see the whole address space here. You see the address space, we can see the whole space here, and then we can see the variables are available in this log window. Okay, so this is the data access. So this one is the address space, and this one is the data access view, and it is showing us the value of this variable. Okay, and here we have a complete log window on the client side, log window on OPC client. Okay, that tells us that how it is being connected. So this is a sort of feedback. It helps us to ensure that our client server communication is working as expected. So this setup is we can also test this setup, and it is a very good learning experience of configuring and making the subscription, okay, for this. Now let's move for, and both are free by the way. Okay, now in this third example, we are moving a step closer to the industrial system. Here we see a Siemens PLC. It is configured, Siemens PLC, and this is the Siemens software for programming, TIA portal. This is called TIA portal, this one, for configuring the PLCs. It is used to program the Siemens PLCs. Okay, this is used to program Siemens PLCs. So what's happening here? And here we have the factory IO, sort of like a virtual factory. And this is how this is connected with the Siemens real PLC. Okay, and in the middle, we notice that this driver is interfaced, and you can see the start and stop and flow things. Everything is being connected and mapped to the PLC here. So the flow is quite straightforward. We have a virtual device in the factory IO, which sends and receives the signals to this PLC, and PLC is publishing these as nodes to the as a OPC UA server here, and then this is further connected to the OPC client. Okay, so the hierarchy is like we have a virtual factory. The virtual factory is connected with the Siemens PLC, and this Siemens PLC is further uh, has the OPC UA server, and then this server is being connected with the OPC UA client. Okay, so through this is a video link you can access and explore further through this video. So how it is being done is in this slide, the Siemens S7 1200 PLC is connected with the factory IO simulator, and this environment is basically the TIA portal environment, where the PLC tags, you see these are all the PLC tags. PLC tags are created under here. These PLC tags are created under your DB data block. So P we can say that PLC tags created under this data block DB1. Okay, DB1. This is DB1, the data block 1. This is the terminology that I should write. Terminology used in Siemens. Okay, for we don't go for deeply there. Our main concern is about the tags. Okay, so there are tags, and in these tags, basically, what are the tags? These tags basically are the tags represent your sensors, actuators, maybe some kind of a tank level, okay, conveyor, for example, limit sensors, set points, okay, also the limit sensors, for example, okay. Now on this right side panel, what we see is we see the OPC UA settings that are made for each of the OPC that will be available to the OPC UA clients. Okay, and in the here we have this is the visibility. Every software OPC client or server, they have different configurations. So first we bring them here, OPC tag, and then we have a lot of check boxes and uncheck boxes. Okay, check and uncheck boxes. Okay, to further configure to further configure let's say, for example, the visibility and also the access for clients. Okay, so it is quite detailed configure. So this you see this all of them are ticked. Okay, checked. So they are visible. So once the PLC is running and OPC is active, so if the PLC is running, once the PLC is in run mode, it is running, and also the what you call uh, the OPC is also OPC UA is also what you call active. Okay, so any then any OPC client can browse, of course, based on the security, can browse these OPC items. Okay, so for example, and the OPC I am for example, the OPC clients can they can be. We just saw that we have the even the Node-RED and also your UA expert or any other SCADA. They can browse and interact with these data points in the real time. So this configuration is honestly is the backbone. This whole thing is the backbone of connectivity using digital twin. I should write it here. So this configuration this configuration is backbone uh, for of connecting your digital twin. Okay, in factory IO to real industrial um, protocol or system. Okay, and you can do a lot of, and what is the benefit? We can test. Okay, we can make a test or any sort of remote monitoring. Okay, and also the dashboards. Okay, a lot of things. Okay, so this is the last slide about the same. In this slide, we are showing you everything from the factory. Okay, so we have a factory here, the factory the factory IO, the factory, and then we have the it is connected to the PLC backend. This is the PLC and plus the OPC server. Okay, and then we have here the OPC client. Okay, so this is how the whole thing is it's done. Okay, so this confirms that the entire communication change from the virtual factory to the PLC and to the OPC client. It's working seamlessly, and it's a great demonstration of basically what it is showing is it is it's like a it's showing the demo of interoperability in industry 4.0 setup. And basically when you use and implement these tools on any real system, basically you are done and you are doing a good step towards the industry 4.0. Thank you very much. Next we will cover the topic from the industrial IoT, but before that I will try to make a small video about the demo of what I have shown here. Thank you very much.